The last concept that we're going to focus on with respect to limits will be infinite limits. But before I do that, I want to take a look at this example here, and it says determine if the statement is sometimes, always, or never true, and then we're going to draw a graph to explain our answers. So if you know that something is true, that means it will always be true, always true. If something is false, that means you have some kind of doubt, meaning it could be sometimes true or never true. So once you have one example where you can prove that this is not going to be true at all or something to negate it, then it's not true. So then it would just be false. So what we want to look at here is if the limit as x approaches positive 2 of the function does not exist, then the limit as x approaches 2 from the right of f of x does not exist. Okay, so what you have to think about is what is the definition of a limit as x approaches some given a value does not exist. Then what is the scenario? So for this to be always true, sometimes true, or never true, you have to go back to the definition. In this case, this answer is sometimes true. And what I need to do is take a look at what would make this true and what would make this false. So a graph that actually makes this a false statement is a graph that looks like this. Okay, so what they're saying is that the limit as x approaches 2 of f of x does not exist, meaning the left and right-handed limits are not going to approach the same value. So what I could have here is if this is where x is 2, they're saying that the limit as x approaches 2 from the right does not exist. But if I have here something like this, here's part of my graph and here's the other part of my graph, the limit from the right exists. Okay? So this actually makes this false. What would make it true is if we have an infinite limit, which we're going to discuss in just a second, but if I have this graph like this, where x is equal to 2 right here, if I had a vertical asymptote, meaning the limit from the right, this is going to be a true graph, meaning this statement right here is true. That means my graph would have to either go towards positive or negative infinity. So if I make this graph look like this, when the limit as x approaches 2 from the right goes to infinity, what we're saying is that the limit does not exist. So in this case, this is a sometimes true scenario. Okay? All right, let's go through definition of infinite limits. So sometimes the limit of f of x as x approaches a does not exist because the values that are assigned to x that are approaching a for the corresponding function continue to grow larger without bound. In this case, we can say that the limit as x approaches a of f of x will go towards positive infinity, meaning my value for y will continue to increase without bound, so I don't have a definitive value. Then, on the other hand, you could say that the limit as x approaches a of f of x is equal to positive infinity is still the same thing as saying the limit as x approaches a does not exist. But again, it's in a special way. On the other side of it, if your values continue to decrease without bound, it's the same scenario, meaning that the limit does not exist, or when you identify the limit and you can see that the graph goes towards negative infinity, you can say negative infinity. So we're going to take a look at this graph. There's our graph. We're given a graph. And here you're given some scenarios. So what we want to look at is the following. So let's take a look at this first row. The limit as x approaches negative 2 from the left. Negative 2 from the left. So here's negative 2 from the left. Where are my y values going? They're going towards positive infinity. Okay, so what's happening is my y values are increasing without bound. Now what if I want to evaluate the limit as x approaches negative 2 from the right of this function? From the right, well, it looks like they're heading in the same direction. This right here is a vertical asymptote. So that means this is also positive infinity. So my left and right-handed limits are the same value. So then if I'm talking about the limit as x approaches negative 2 of f of x overall, the behavior of the graph, or of the function, is exactly the same. Therefore, in this case, it's a very special or unique situation where you would say the limit as x approaches -2 of f of x is equal to infinity. You can say that the limit does not exist, but this does not exist in a special way, meaning your values will be increasing without bound. So if I take a look at the function evaluated at -2, here we see that it's a vertical asymptote. We would say, okay, f of -2 does not exist. So does that happen if I say the limit as x approaches, I don't know, let's say 0. The limit as x approaches 0. Does this exist? No, this does not exist. Why doesn't it exist? Take a look at your left and right-handed limits.